either the career options was a design or into construction. Very little is usually covered, and I'm not talking this only for VIT. If you talk about across the any other universities also, very little coverage has been given to the importance of construction chemicals. Now, construction chemicals is a very interesting field. First of all, it's a products industry. So, like there is cement, there is fly ash, there is sand, there is coarse aggregates, and now the fifth ingredient, which has become very important when you are doing a construction, is a construction chemical. Now, uh, as I move to the next slide, so what are construction chemicals? During the course of this presentation, I'll try to keep it short because obviously I had paucity of time. So I did not make it very detailed also. And at this level, I think we have the second or third year students. So can you confirm me?
First year, second year, final year, third year, as well as master students also will be looking.
Fantastic. So
Masters in construction technology and management and structures, and from some other department also is.
fantastic, fantastic. Because what happens is, I do these MTech construction management classes for IIT Delhi also. And it's very important for the planning managers of tomorrow. Say many of you will choose construction as an option, as a you will be a GET or a site engineer in some of the top companies, in contractor companies. It is very important to know that construction chemicals can actually come to the aid of yours, and and help you get rid of a lot of problems you will face on site. And how will that happen? So we'll talk about the same thing right now. So construction chemicals is a very interesting word. It's a fusion of construction as well as chemicals. So you must be wondering what is exactly the right way to present it. So how I present is, it's actually the use of chemistry in the construction and civil engineering sector. So, construction chemicals broadly are defined as chemicals, compounds, or formulations that are added to the construction materials, particularly concrete, in order to improve their workability, enhance their performance, add functionality, repair, protect the construction material, or even the finished structure made out of it. So, as we go along, I've done this slide for you to make it, because what I'll try to make is, I don't want to make this presentation very boring. First of all, let us understand that I'll try to break it down as much as I can, just like a layman, so that you can get some interest into this field. Then you can go out, obviously, out of this presentation, and then you can do your own study if it interests you. And you can always come back to us. I'll share my details in the last slide. So construction chemicals is nothing but the pharmacy. We call it the pharmacy of building materials. So I actually had a little, I have a creative side where I wrote this poem when I was doing my master's in structural engineering, where I was comparing cement with human beings, right? So just like human beings have their life, cement also has a life which has evolved over the years. So just like human beings who can have various diseases or have problems, similarly concrete can also have diseases and problems of its own. So whether in human beings they have a problem of, say, a dehydration, and then you run to buy a glucon D or something to energize yourself. Similarly, concrete can also have a problem of dehydration, which is called something like poor workability. So all of you have already studied your concrete technology courses, so you know what workability is. So that is nothing but when you don't have sufficient fluidity in the concrete. So that's a problem which many times concrete has. Other than that, another problem which concrete can have is, or human beings have, is that they have wrinkles, they have issues in their skin, for which they have creams to help make their skin very smooth, moisturized. Similarly, in case of concrete, they have a problem called wrinkles, which is called nothing but a shrinkage cracks. Now, shrinkage cracks, these are also problems which can be dealt with using a construction chemicals, using different kind of coatings, which can help make that particular crack go, and the surface will be very smooth and seamless, just like the human skin. In human beings, there is a problem which we call as cancer. So the same cancer for a concrete and for reinforced concrete especially, and many of you have already read about it, is called corrosion. So if you see both human beings and concrete, they have similar problems. Luckily for human beings, there are so many big pharma companies who are offering all kinds of medicines. And luckily now for concrete also, there are medicines which are in the form of construction chemicals. So right now I want to explain you the stage wise use of construction chemicals. So when you are constructing a building, and it can be any, it can be a dream home which you can be building. You can be building a dream home for your mother, your parents, for your next. I mean, you are very young, so once you grow, you get married and all. There will be requirements for buying your own home. So when you're constructing a home, construction chemicals can be used at various stages, starting from the point when excavation happens, and once you lay that first layer of PCC, or you have an isolated footing or a raft foundation, that is when the construction chemical use starts. First of all, you need to understand that wherever there is cement these days, there is something called as plasticizers and superplasticizers. Many of you have already read about it. I'm assuming it is also generally called as admixtures in our industry. Now, these are something which is added inside the concrete to increase the fluidity and the workability of concrete that I've already talked about. After that, once you've added these admixtures, these concretes which are foundation, you need, because they will have exposure to groundwater. So then there comes something called as waterproofing admixtures also, which are added inside the concrete. And that is how you start with the entire I would say the construction starts. So from there, then as you go along, then you will have retaining walls. The retaining walls will also have something called as waterproof coatings which will be applied. And also bear in mind, when you are pouring this concrete inside the mold, even for demolding that particular concrete, there are surface treatments available there as well. So for demolding, we call something called a shuttering oil. These are nothing but mold oils. The old school way of doing is that people use burnt lubricants, burnt diesel, mobile, and which is not recommended because they are very acidic in nature. They will corrode the concrete. So that is where we recommend that you can use something called shuttering oils. It's nothing but looks like an oil. It is used with a brush. You can simply apply on the mold, and then you can demold it very smoothly, and you will get a fair faced concrete rather than the concrete getting stuck to the mold, and then you are having all delamination happening. After that, there's another product that is called is bonding agents. What are bonding agents? Bonding agents are nothing but when you are doing concreting, and say the day has finished, say 7 o'clock or 8 o'clock, and you are doing a concreting of a slab, or say a terrace slab. So it is possible that you will finish 50% of the concreting, and then the workers will say, sir, it is already night, I'm going back home. So tomorrow I will come back and finish the remaining concreting. So the next day when the person comes and starts concreting again, there are chances that there is a joint that can be developed at the point where he left the concreting. So to get rid of that joint, because see, remember, if it's a terrace, that joint can be a potential source of leakage and water seepage. And then you will start facing all kinds of, waterproofing issues, and problems will happen. Your steel will corrode. That is where you can say that we can use bonding agents. These are nothing but, these are various kinds of chemicals, you can say. You can take it with a brush, or you can spray it, and also in some cases, and just simply you apply it on the the old layer of concrete, and then the new layer of concreting can start from that particular layer. So that is bonding agents. Then there is something called pumping aids. Now, what is a pumping aid? Pumping aid is something, and all these things, some of these topics I will be describing in bit detail later on, also in the form of some videos also, which I've tried to get it so that it is easier to relate in, I would say, a video memory or visual memory is stronger than textual memory. I always believe that. So we'll talk about that later on. So pumping aids are nothing but, so right now you can see India is right now growing like anything. It is going into high rise structures. Now imagine a Burj Khalifa which is having, I don't know what, millions of floors. Imagine sending the concrete to the topmost floor. For that, they are using pumps. If you have seen, they are putting the concrete through a hopper. Then there is, they will have a boom and everything is there. They put the concrete in the hopper, and from there they'll pump it to the topmost floor. For pumping it, you need to have, in that pumps, the pipes that you can see, you need a liner which is needs to be applied on the pump, so that the concrete can easily, move through that particular pump or through that particular pipeline. And that, for that also, there is something called pumping aids that we are having. These pumping aids can be simply, once you are, just making the concrete move, or maybe you can have a slurry, or on which you can put the pumping aid. Simply, if you once prime that particular pipeline using this pumping aid, then you can easily pump the concrete to the topmost roof or any farther distance. After that, once the concrete is being, constructed, and then you, as you coming to the ground floor and upper floors, the curing compounds can be used. Now, what is a curing compound is, as you can see, India is right now, or maybe recently you have read in news, countries like South Africa, they are struggling with Cape Town. I think you must have heard about it. They are struggling with water. I mean, Middle East is very well known that there is, scarcity of water. Even India, for that matter, is facing scarcity of water, as we, if we are not responsible right now. And water forms an important part of curing in concrete. So many of you are casting, concrete cubes in your labs under the guidance of, Bala Murugan sir is there, there is Sairam sir is there. So once you are, casting those cubes, you are putting it inside the water to ensure the curing happens. What will happen is, it is a continuous hydration process through which you are going to activate the unreacted cement particles, and the concrete attains the necessary strength. So what we are suggesting, or as a construction chemicals industry, we suggest that don't need to use this water. Save water, especially in case of columns. You can see right now how they do the column curing is, they will simply tie some gunny bags around the columns, and they will, spray water from the pipe on the gunny bags. So that is not a very recommended way of curing, but people do it. One of the easier ways of doing it is, you can simply use a curing compound, which is nothing but, it is wax is one of the important components of this curing compound. So you can imagine wax, moam, like you will have candles and all that. It is wax based curing compounds, and there is another curing compound called resin based curing compounds. These are nothing but liquids. Simply, again, you can spray it, or you can apply it by a brush, and you can apply a layer on top of the column. What will happen is, the moisture which is there inside the concrete, that is not evaporated, that is not lost, and with the same moisture, that entire concrete inside gets cured, or the curing happens. So you don't need external moisture, like by putting, say, pipe water or something. Through the internal moisture only the curing happens. This is also a very important part of construction chemicals. Then as you go along further up the floors, you will notice that, then you come to something called as finishing, the finishing part of any building. In finishing, what all you do, you put tiles. These days it's a fashion to have tiles. So even tile adhesives, which are for pasting the tiles, and then there are tile joint fillers. Even these products right now are gaining popularity. They are also part of construction chemicals. Then you have something like joint sealants. You will see, these days on the window joints, or maybe the door joints, you will have some sealants. Many people have heard about silicone sealants, acrylic sealants. Now, these are nothing but, these are very elastomeric kind of, I would say, compounds which are applied, so as to ensure that there is no, opening left around the windows or the doors. So it seals those joints. So these are called joint sealant. That is also heavily used. And finally, once the terrace is completed, then you will have some kind of a waterproofing treatment. These days, you must have seen on the TV, many companies have come in the field of waterproofing. There are people who never did waterproofing, who were selling cement or a paint, have now also started promoting waterproofing. Luckily for us, we have been doing this for the last 40 years. So this is not new to us. So as you can see that construction chemicals has become mandatory, and it has now become very important if you talk about in any building or any. So not only building, this is a real estate building that I am showing you in this particular pic. It can be any project. It can be a road project. There are chemicals which are needed for road projects. It can be a tunneling project. It can be an infrastructure project, say a port or a commercial complex. You just name it. Anywhere you have cement, which is used as one of the main building materials, you will have a construction chemicals which will be used. So this is the entire construction chemicals family. So let us say it this way, that each, this is called the segment of construction chemicals. It can be divided into waterproofing, concrete repairs, adhesives, concrete admixtures, grouts and anchors, protective coating, sealants, tile installation, industrial flooring, and cement additives. So obviously, all of these segments have at least 15-20 products within them, which are, constituting that particular segment. And we as a company are also producing all these chemicals for the last so many years. So what I can say in short, this pretty much represents the construction chemicals family. Today in the presentation, I would cover up only on a few major, I would say, topics like say concrete admixtures and waterproofing, because you don't need to know everything. And just to give you a little a small tip, if I were you, because I have, I remember when I was during doing my BTech, we used to have these guest lectures, and my idea was very simple. You may not understand everything. The chances are a lot of things can be, just simply they can pass overhead. But I would suggest, make some keywords. If you are noting it down somewhere in your room, in your house somewhere, just make some key points, keywords, and then study about it later on. There's enough content out there. You can do Google, you can do YouTube, and you can, you can see about them. I would suggest, don't even read about them, just watch videos. That will help you understand more about this particular stream of civil engineering. Okay, a bit about our company, why you should listen to us. I think it has been already been very well covered. So we are a very old company, more than 2 decades old company. So it was founded by the late Dr. Dhananjay Ghanti, who was also known as the first construction chemicals chemist in India. And he was a big face. Any big company in this space, any MNC in this space who launched themselves, he was responsible behind that. And he was responsible, in fact, for training and doing seminars same way, because today construction chemicals is very well accepted. Many of you have already heard about waterproofing because of the media coverage and all. There was a time in 1990s when no one even understood about what is waterproofing, what is an admixture. People used to be trained. They used to have 4 or 5 days of training to understand. They used to think chemicals, oh my god, will this tear out my concrete? Will this totally break away my concrete? Why would I add a chemical inside inside a concrete? But you know uh, now people have accepted it because it's needed. It's very well documented now. I also wanted to tell you about the Indian construction chemicals market. Why I'm covering these points is a reason behind it. I want many of you at the end of this session to think about, and many of you in the third year and the fourth year, to think about construction chemicals as a career option as well. Being from the industry, I can today say that the construction chemicals, the there is a manpower crisis. Let me put it this way. So when we are trying to hire people, we just feel there aren't sufficient people who know the subject very well. So you need to understand that what's the advantage or what's the potential of this particular industry. This industry, as I already told you, 2 to 5% of the construction cost comprises of construction chemicals. There is a huge change in the government policy. As you can see, there is more focus on quality. So construction chemicals plays a very important part in that. It is also very important for energy conservation. I will touch this point in the last slide. You will understand there is a green footprint of construction chemicals also, and sustainability. Sorry. This industry till last year would be somewhere around 10,000 crores, around $1.5 billion market, you can say, by 2020. So again, this industry is growing. So the mature markets like say China or US are more than 1 lakh crore. The industry is worth more than 1 lakh crore. So you can imagine there is a huge interest in construction chemicals. In fact, I can tell you, whenever a Modi or an Amit Shah comes on, on media and they talk about a huge budget being kept aside for roads and for infrastructure projects and all, you can almost just simply multiply that with 2%. That is the potential of a construction chemicals, that is going to come up in the upcoming years. So as you can understand, with so much of lakhs and lakhs of crores being spent on India's development, and India is growing very fast right now, you can imagine that there will be requirement for more and more quality manpower also. So historically, construction chemicals, greater than 80% business is actually in new construction. But right now, as India is getting older, so you would expect that remedial market, repair and rehabilitation market is also catching up very fast. In fact, if you look at the houses which your maybe grandfathers are staying, they must have reached a stage somewhere that where they need some kind of a treatment. And for those treatment, it is construction chemicals only which can come to the aid. Forget about just using a cement sand. We used to say just use a cement sand masala, apply it, and you are done for the repair. No, it won't work like that. Now you need to use the construction chemicals for repairing those old buildings. Traditionally, obviously, as you can understand, admixtures are something which is added inside the concrete. So the percentage of usage of admixtures or the turnover of admixtures is actually much more in any project than any other product of a waterproofing or sealants, because it goes along with cement. So let us talk about admixtures right now. So I'll quickly give you a brief bit about admixtures. You can see this wonderful image of a concrete being pumped, but we'll talk about it. Now, first of all, let us understand why you need admixtures and all that. Let us set a stage right now. Now, normal concrete is inherently porous. It is very well known. The average total pore content of any M30 grade of concrete will be anything between 14 to 20% by volume. Many of you have already read about it. It's a bit of a revision that mainly there are three major pores that you will find inside a concrete. There is the gel pores, which affects the strength and durability. There is the capillary pores, which affects the creep and shrinkage. And then you have entrapped air voids, which is due to the poor compaction. And I think you also know that there is a rule of thumb says that for every 1% of air voids, there is a 5% strength loss. Now, why is concrete porous? Let us understand that also. So now let us take a typical concrete mix which is having cement of say 350 kgs. The water cement ratio is somewhere around 0.5. So the total water in the mix will be 175 liters. Now, as per Neville, if you have read about Neville, and I am sure many of you have read about MS Shetty, the great MS Shetty and all, the amount of water that is needed for hydration is only 0.28 water cement ratio, which is coming out as 98 liters, which is needed for the hydration of the cement particles. But still we are adding 77 liters more water, which is also called the surplus or the free water. And what is the purpose for adding this free water? That is to give the workability, to give a little flow to the concrete, so that otherwise the concrete does not flow, then you cannot place it inside the slab. So this water of 77 liters, but the negative side of the 77 liters is it migrates to the surface of the concrete and it leaves a network of interconnected capillary pores, which will have a volume of around 77 liters. Now, as you understand, as per this particular formula, almost 7 to 8% of the volume of concrete is porous network. Now you will be concerned. So if you have a porous network, then there is likely movement of waterproofing issues may come up later on. There'll be many more issues. Cracks will happen, shrinkage, this, that. So what our idea is, one of the possible ways of overcoming the excessive water usage is to use admixtures. So what you can do is you can reduce this water. This 175 liters of water can come down to say 150 liters of water. So then automatically what will happen is the water cement ratio will go down. And I think many of you have read in Abraham's law is lower the water cement ratio, higher is the strength. So you will get the strength. But what will happen to the flow? That will be taken care of by the admixtures. So now I'm just giving you a little bit of an SEM image of what a concrete looks like. So if you see, calcium silicate hydrate gels, many of you already know, there's nothing but needles type structures. Now, you see the capillary pores, the areas which are not occupied by any hydrated cement particles. Now, these are the areas which are potential problem points. Now, this is happening because of the excessive water usage. Now, what we are trying to do is we are trying to bring down this water, use this admixture, and what are the types of admixture? Let us understand that. In the market right now, there are mainly three types of admixture which are being used. One is a lignosulfonate and a naphthalene. One is lignosulfonate. That is a first generation admixture. A lignosulfonate admixture would reduce water up to 10%. So if you are having 180 kg of water, it will reduce up to, water up to around, you can say 15 kg, 15 to 18 kgs of water. Then, science improved, chemistry improved. Then we got something called naphthalene, SNF based admixtures. Now, SNF based admixtures cause water reduction as high as 23%. So you can imagine there is much more water reduction, which would mean the strength increase will also be much more. And finally, polycarboxylate ethers. These are the latest third generation, or you can say fourth generation admixtures, which are giving you water reduction as high as 40% and also giving you strength increase, because obviously if the water comes down, the water cement ratio will also go down and the strength will go up. Now you must be wondering that by reducing 20-30 liters of water in 1 cubic meter of concrete, how are we getting such kind of flow? The answer is, when you are adding these kind of chemicals inside the concrete, it there is a certain mechanism through which what happens is the cement particles liberate the water which is present within them, and that water is the one which is giving you the flow. So it is not introducing any additional water inside the concrete. What is happening the moment you are mixing cement, water, sand and aggregate, the cement has a tendency to agglomerate. You must have seen that, to come closer to each other. It is because of the surface charges which are there in the cement particles. So when you are adding these chemicals, and this slide mentions it, so when you are adding these chemicals, what it happens is, if it's a ligno and SNF based admixture, it it is nothing but it creates a negative zeta potential, or creates a negative charge around cement particles. And I think many of you have already known, like charges repel each other. So the moment you have negative charges, automatically the cement particles go away, and the moisture which is locked inside, or the water which is locked inside, gets released, and that's how you get the flow in the concrete. Now, I will just explain you what are the roles of admixture. I think there's nothing to explain. You can see it very well. So just imagine, concreting this dense, heavy, steel. You can see that, heavy steels are being used because must be a basement of a big mega high-rise structure, a basement column maybe. And imagine sending concrete inside this. You cannot do it but without using an admixture. Number one. Number two, if you want to reduce the bleeding and the segregation, one of the ways of doing it is to reduce the water content, and that again will happen only by using admixtures. Next is a cold joint removal. Why I am saying cold joint removal? The same thing. When you are concreting and then you're leaving it overnight, and then the next day you are, or maybe you're continuing after 3-4 hours, the concrete need not set. The concrete has to be somewhere, we say it is still alive, so that it is, that even when the next level of concrete is poured inside it, then the two gets intermixed. If this concrete sets and then you put another layer of concrete, again a joint will be formed, which can be potential point of water ingress and all. So for that also admixtures are used. Also, it reduces the drying shrinkage. That is again a byproduct of reducing the amount of water content. Another role of admixtures is ease in transportation and placing. You can see this particular photo. Okay, there is this video again, just to put things into perspective. You can just see, and maybe you will able to understand that why we are talking about what is the advantage of having admixtures. So I'll just quickly just fast forward it a little bit also. So you can see this is a dense structure. Now look at this concrete. This such beautifully, it is, it is almost, you can say it's a self compacting concrete. It is compacting on its own, it is flowing on its own. It is not being needed to be taken out through, you have those trowels and all people are using. It is flowing on its own. Now this is only, and look at the concrete mix, there is no segregation, no bleeding, everything is moving in unison. Imagine cement, aggregates, everything has a different specific gravity, and still to bring everything together and make it move at easily together, it is only possible through use of admixtures. It's a very good video to just understand what this can do, the potential of, you can say, an admixture, this thing. Fine, I think we will just quickly move on to the next slide. That's understood. So now we will talk about waterproofing. Now this is again a very important field because, as sir said a while back, uh, Tamil Nadu, Chennai is going through a bad time right now with all the rainfall and everything. So there will be huge requirements for waterproofing and all. Now, first of all, let us understand what a waterproofing is. Sorry. Waterproofing is nothing but you can say it's a formation of a barrier to prevent passage of water through concrete due to various water transport mechanisms involving penetration through concrete and openings. And in short, it is a way to create a barrier to prevent any moisture ingress. Now, waterproofing is something which in technical terms, we say waterproofing is anything which is in presence of hydrostatic pressure. So what is in hydrostatic pressure? So if you're having a water tank, and imagine the lowermost slab, if you have a tank, a concrete water tank, the lowermost slab, or say a swimming pool, which you have a swimming pool, when you put water over on top of the swimming pool, obviously that particular water, if it is say 2 meter height of water, 3 meter height of water, it will have some kind of a pressure which will exert on the concrete slab. Now this height of water is likely to cause you issues because under the pressure of hydrostatic pressure, this water can penetrate through any cracks or joints that are present inside the concrete and cause issues with your steel and everything. So waterproofing is something which is because of the presence of hydrostatic pressure, whereas dam proofing is the reverse. It is in the absence of any hydrostatic pressure. So many of you, if you go back to your old homes, I'm sure today all of you are pretty much well, I would say, endowed with good homes. But earlier, what happened during our dad's time or maybe grandfather's time, the basement, and even today it's happening, the basement of the floors are usually facing, we call it in Hindi papdi happens, like you will see dampness and seepage happening at the ground floor. So that now you will say that there is no hydrostatic pressure over there, but how is that water reaching over there? It is because of the capillary action, that because of the water present in the, you can say, in the ground floor or maybe below the ground area, that moisture is rising through capillary suction, and it is causing dampness, and it is rising to the walls of the ground floor. So this is actually nothing called but a damp proofing situation. It is not waterproofing problem, it's a damp proofing problem. Now you need to understand that there is a difference between the word leakage, seepage, and dampness. So leakage is something which is called a continuous flow of water, then that is where you say a leakage is happening. A seepage is something which is formation of water globules, but not necessarily moving. It will be there. And thirdly, dampness is just visible moisture, as I was talking about. You can see this last photo. So you can see there is dampness and wetness, which you can feel by palm. If you run a hand over it, you will see there is a lot of moisture over there. So that is a dampness issue. Now let us understand, why do we need waterproofing? It is important to go behind the science why the waterproofing is needed. Now you need to understand, see, porosity and permeability are not the same thing at all. A highly porous material might perform well as long as the pores are not interconnected. But in a case where the pores are interconnected, that is, and even if the pores are less, it is a much more dangerous situation, because a high porosity and a low permeability case would be obviously when they are not interconnected. But when the moment they are interconnected, then that is where you are allowing free passage of water to the steel and the entire, the concrete mass. So that is where you need to understand that you may have a highly porous concrete, but yet it is not highly permeable. At the same time, you may have a less porous concrete and it is still highly permeable. So that you need to understand. Now, I think I have already covered this slide in a previous thing, but I'm just making this revision to you, that yes, we have already talked about the fact that there are pores which are present inside the concrete. So this is the same thing which I have already talked about before. Now that is the not, this is the porosity which is coming naturally inside concrete. This is not any porosity which is because of any one of our actions, But what happens on site because of some anthropogenic or some human actions or some mistakes that the quality manager of any particular site does, there can be reasons of permeability inside concrete as well. So what are the reasons? One is poor compaction. Many of you know that if you don't compact the concrete, you will not release the entrapped air voids, and those air voids can actually be potential point of entry of water. Number two is curing. And as I have already covered, curing is very important. If you don't cure, your concrete unreacted cement particles will not hydrate, and automatically what will happen is you will have a porous concrete. Another problem is high water cement ratio. Now what I mean by high water cement ratio, many times what happens in on the site these days, you have seen, you have transit mixtures which are sent to site, the trucks which will have, drum inside it. These transit mixtures, when they are being sent from a batching plant to the site, the moment they reach the site, they notice that the concrete has died. By died, I mean that the concrete flow is not happening. So it's possible that they have designed that particular concrete at a water cement ratio of say 0.45. By the time it reaches the site, it has dried out because the site was around 2 hours away from the batching plant. And now the truck driver, he is a big concrete technologist, because he's driving the truck, he has the entire power. What he will say, to save himself from sending that material, rejected material again to the plant, what he will do is he will add some water without anyone knowing inside that particular mixer. So what will happen is your water cement ratio of the concrete which is present inside that mixer has gone up. And automatically, these are some real life problems which you will not come across in academics, but then these problems happen on site. And that is another way through which you are introducing more water, which is a higher water cement ratio, and hence there will be more chances of permeability. Lastly, there is presence of cracks and joints. I've already talked about the presence of cracks and joints. It is one of them is cold joint I've talked about. Other than that, you already know about shrinkage cracks, plastic shrinkage, drying shrinkage cracks. Now, these are cracks which will happen if you do not follow the right concrete mix design or concrete placing practices. And then there is thermal expansion, thermal cracks as well. So what will happen is once these cracks, they interconnect, they will leave, a kind of a, you can see that, this interconnected a line they will leave, and then you will have steel somewhere in the bottom. So just see what happens. So what happens? The water will start entering inside that particular concrete, and it will come closer to the steel. Then you will have carbon dioxide which will enter through those pores into the steel, and then you will have chlorides if it's close to the sea water, or sea maybe close to a beach, like say Chennai is next to the coast, so it's a coastline, so that's where you will experience this kind of problems. So now what happens, the moment these three ingredients reach inside the steel, they initiate a process called corrosion, which I am sure many of you have already read about. I don't want to talk about it in detail, but anything the in simple I'll say that in corrosion you will have two places, there will be an anode, there will be an cathode. So all your rust gets accumulated, at the point of cathode, and what happens, the moment those rust gets accumulated, the volume that this rust is almost in some cases 6 to 7 times more than the steel itself. So what will happen, automatically such volume, to accommodate that volume, it will crack, and that's where the cracking will happen, they will be spalling. And so many of you already know that that is why people say that you should always try to keep the concrete in an alkaline state, because the moment it is in alkaline state, you will not have these corrosion problems. Again, a classic, a synonymous or analog that I can use is even human body. We are happy when we are in alkaline state. The moment you eat outside, say, some kind of pakoda or some kind of, I don't know, I mean, because in South India, I think dosa and idli is, they are very safe food, but sometimes when you are having some oily food outside, they tend to cause acidity, because that reduces the pH inside our body and it causes us issues, and then we are like huffing and puffing. Similarly, inside the concrete. So when you're introducing the fast food, like say in this case, what is the fast food? A sulfate, chloride, carbon dioxide. That is where it initiates the process of corrosion and the cracking of concrete happens. So now overall you can see this, there are around 9 to 10 deterioration mechanisms. There are something more than 11 in fact, but I identified all these deterioration mechanisms inside concrete. So there is erosion, thermal cracking, there is drying shrinkage, plastic shrinkage, alkali aggregate reaction. Many of you have read about it, I think. Chemical attack, freeze and thaw, rebar corrosion through external chlorides to internal chlorides through carbonation. So all of these deterioration mechanisms inside a concrete, what is the common point to all of them? It's water. So it is very clear that we have to find a way to keep water outside the concrete. Now you will be thinking, you will be confused. I was confused when I first heard about it, that in one place we say that water is needed mandatory for concrete because it causes hydration. On the other hand, we say that this water is also the main reason for all the problems that the concrete is facing. So it's a double-edged sword, you can say. So in plastic state, we want water to be there inside the concrete because that is where the hydration of the cement particles is happening. But the moment the concrete has reached a hardened state, you do not want any water to enter inside the concrete. And what is one of the ways of doing that? It is through waterproofing. And that is where we have arrived at waterproofing is important. Earlier, many of you must have seen our great grandfathers and all. They use something called as the bucket technology. The moment there will be some seepage or leakage from some kind of a ceiling and all, they will use a bucket, and the the entire problem will be resolved. But now luckily, again, earlier there were use of bitumen. People used to think that black is waterproofing. That is a wrong thinking to have. Never have that thinking. Bituminous products are, first of all, they are health hazards, many of you know. Number two, they do not have any UV resistance. They're likely to degrade over a period of time. So these are old school ways of waterproofing which people use, and now people have now moved out of the system. This another way of doing waterproofing. Earlier was creating a slope. I feel that making a slope is the best way to waterproof any terrace, because the moment you allow water to sit over the terrace for a long period of time, you will have waterproofing issues. So one of the ways of doing it is make a slope so that it goes to the nearest drain point, and then the water gets collected and it goes through the pipes to the eventual place. So now we'll talk about what are the types of waterproofing. So waterproofing is essentially of two types, I can say: integral and external. So integral waterproofing is nothing but where you are putting the waterproofing material compound inside the concrete, and that is where the action happens. And the second way of doing it is you let the concreting happen. It's more of a post construction treatment, that the concreting has happened and then you are applying a coating or a sheet membrane is being applied on top of it, and that is how you are waterproofing. What are the typical properties of any waterproofing material? I think I will skip this side. It is very well known. A main property of any waterproofing material should be it should resist water. That is very important. And other than that, obviously, it should have good UV resistance. It should have good bonding with the base substrate. So all these things should be there. So let us talk about the crystalline waterproofing, how it looks like. So this is one of our products only, which we'll just put the video on. Maybe you will able to understand how a crystalline product works. So it is again a type of an integral waterproofing. So crystalline waterproofing, I'll just give you a bit of a brief. Crystalline waterproofing is nothing but these are like powders. It looks like a cementitious powder. It is added inside the concrete when you're making the concrete. And this particular crystalline powder, what it does is it reacts with the byproducts of cement hydration. And the moment there is a leakage, so obviously there is a water moisture ingress which is happening, and in the presence of that moisture, that entire crystals get activated. So the moment those crystals are getting activated, it is going to physically block those pores, and automatically you will get a waterproof concrete. So we'll see this video. You will be able to understand. You can see that when the moisture enters, crystals are formed, and these crystals are the ones you can move to the next slide now. Um, so that is one. Other than that, there is we also called there is product called the other form of integral waterproofing is hydrophobic pore lining products. Now, hydrophobic pore lining products are different to the pore blocking technology. So, in a pore blocking technology, what happens? It is physically blocking the pore. So, another way of doing it is if we can line those pores with a chemical which can resist water. So, that is a chemical, more of a chemical mechanism. The earlier one was a more of a physical mechanism. So these pore liners, if you many of you must have heard about it, say silicone repellents, many of you must have seen, or maybe just imagine when you have a sun mica table, and if you put a pour of drop of water on top of the sun mica, you will see the water will remain like a drop effect, a bead effect will be there. It would not absorb that particular moisture. That is actually because of this a product which is there. There are silicone and siloxanes, silicones and siloxanes and silanes. That's another family of products. I'm not getting technical stuff, but you need to understand there are pore lining technologies also which can create this kind of effect, as you can see. So we'll just quickly just so you can see So you can see this, why this effect is happening is because of the presence of this kind of a coating, or which you can maybe either it can be applied as a coating or it can be added inside the concrete. So you can see this is the effect it will form. It's a bead effect. And here you don't have any this pore lining technology. So remember, this is not any physical mechanism. Again, it's a chemical mechanism. It is resisting. So it works under the principle of it works under the principle of, you can say, surface tension. So if you know that when you are applying this coating, it reduces the surface energy of the concrete particle, and automatically the moisture which is there, because it is having a higher surface energy or surface tension, you can say, it does not absorb that particular moisture. So again, this is the second type of integral waterproofing, again, which can be added inside the concrete. The third type of integral waterproofing, many of you have already studied about it in your, I think, classes. It is called microsilica, fly ash, and GGBS. These are also called pozzolanic material. It is nothing but it is having reactive silica, which is reacting with the byproducts of cement hydration, and then it is creating more calcium silicate hydrate gels, which gives additional, I would say, impermeability inside the concrete. So this is also a very traditional way of doing integral waterproofing. So okay, fine. And then the last of all, another way of doing integral waterproofing is, we have already talked about it, we can simply reduce the water cement ratio. because the lower the water cement ratio, the more refined your pores will be, the more they will be not interconnected. So that is one of the very easiest ways of doing integral waterproofing. So for that, again, superplasticizers can be used for reducing the water cement ratio. So this is the integral waterproofing. So integral waterproofing, as you can see, the main advantages are that it makes a very durable concrete. It is not prone to any surface tears or damage. It does not require any maintenance. It reduces the construction time. But on the other hand, you can see that, sometimes people say that they are not very effective. There is also, there are two sides of the story. But overall, right now, if I talk about integral waterproofing, they are doing very well. In fact, many of you must have seen ads, advertisements of few companies who are selling this integral waterproofing. I think some famous companies like, say, Dr. Fixit. Many must of you seen that LW Plus. You can see Amitabh Bachchan sitting with two products. One is URP Joda. He'll say all these marketing gimmicks are there. So one of them, that is the LW Plus, or in our case, we have a product called D001. That is again an integral waterproofing product. When you are adding it inside the concrete, it's creating the waterproofing effect. Now we will talk about the external types of waterproofing. I would not go through details of single product. You just need to know the mainly the families or the chemical families which are constituting this exterior waterproofing. One is silanes, then is the siloxanes, these silicones. These are again all coatings. These are transparent liquid coatings which are applied on the concrete. Then you have acrylic coatings, epoxies, polyurethane. I'll show you some videos. I think then that is where you will be able to understand it better. So, so these are mainly the 7 families of liquid waterproofing coatings. So earlier was the integral waterproofing. These are the surface applied waterproofing or the external waterproofing. So we will talk about the most popular waterproofing right now. That is the polymer modified cementitious coatings. Now, what a polymer modified cementitious coating is, you can imagine it as it is mainly two parts. It's a two-pack product. One is the polymer, one is a cementitious powder. The polymer is nothing but it looks like a like a milk. So you can, whenever I'm saying a polymer, you can imagine an emulsion like a milk, which is mixed with the cementitious powder in a desired ratio, and then you make a slurry, and that slurry can be applied on the surface. So you can see this video. One second. So you can see that there was a polymer and then the powder is being added inside the polymer. So you can see that it will create a slurry like this. This slurry, when it is made, can be either applied by a brush or you can spray it. You can see such a smooth creamy mix has been formed. Now he has put it in a hopper. He will spray it. So you can see it's a very porous surface. He is applying it is being done. So usually you will have 3 layers. What happens now is some then you can apply the second layer. This is a cementitious product. This is early modified cementitious product. What it does is combining both the good properties of polymer cementitious is giving you high. You can understand that. Fine. So we'll now move to then there is another type of surface coating products. Now these are like acrylic based elastomer coatings. Over here you do not have a cement or or a, you can say, an emulsion. You simply, it looks like a paint. You simply take it from the bucket and put the brush inside it, and then you simply apply this particular. So this is surface preparation. So it's very important that before any concreting is done, sorry, any coating is done, you have to prepare the surface. The surface is prepared only mainly by, making it, in a slightly SSD condition. That is, the surface is slightly moistened with water. And then you are applying, then they are obvious, in this case, they are applying a kind of a cementitious slurry. And then the entire coating is done through, through a brush. So this is the coating that they are applying. So in this case, they are using something like a glass fiber mesh. This is again a kind of a mesh which is used between the first and the second coat. The main purpose of adding this mesh is it gives you more tensile strength to the entire coating. And so the coating can be protected from any kind of cracking in the future. So you can see such beautifully done. It is all white. So this is also going to give you very good solar reflectivity. It is going to keep it cool also. So okay, and so now, so obviously in this particular case of coatings, you can have two types of systems: a solvent-free and a solvent-based system. I don't need to cover it because it is a bit too advanced for you. So this is the summary of the fluid applied, that is liquid applied coatings or the external waterproofing. So mainly these 6 or 7 which I've already talked about: polyurethanes, epoxies, silanes, acrylic coatings, crystalline coatings, and polymer modified cementitious coatings. These 6 or 7 are the main kinds of coatings that are present in the market and which can be applied, and they can take care of your terraces or maybe a swimming pool or water tanks. So that is used in various places. Now, other than liquid in external waterproofing, either you can have a liquid applied waterproof coating, or you can have a sheet membrane systems also. Now, sheet membrane systems right now in the market, there are mainly around 5 kinds of systems. Like there is an APP system or an EPDM based system. Now, these are very high end technical terms, so don't need to worry about it. I'll just show you a video because this is one of the very commonly used system that people are using. So so this is again kind of a, you can say, a sheet membrane system. I'll just show you the. So in this sheet membrane system, what happens? First of all, the person applies a primer on the surface. So these are bituminous primers which you are applying on the surface, and then the membrane is, it's a preformed membrane. It is already coming in rolls. You simply need to, as you will see, I think you simply need to use a torch. A torch is nothing but, it is like a, no, you can see it's a kind of a heating, it's a flame, it's a heating flame is there. Through that flame, what they do is they melt the, these are like, this comes in sheets. So obviously they melt the bitumen which is there in the beneath that particular sheet, and that melts, and that bitumen is the one which gives the adhesion to the sheet membrane. Yeah, you can see this. So as you can see, there is an overlap. So it comes usually, around 1 meter wide, and there are around 20 meter length is there of these rolls. So these rolls are simply, they are laid, they are, melted, and they are simply then moved on. Again, you can see this is one of the very, I would say, old school systems right now. There's a problem with sheet membranes. As you can see, the bonding which is being done between, there is always these joints. My concern with these systems are that you have joints which are there. There are seams are there. Though these joints are the ones which generally open up after 3-4 years down the line, and that is becomes a point of, a moisture ingress. So I don't prefer these systems. I would say I would much rather use a liquid applied coating, which I showed you the video before, where you can apply a coating and it is a seamless coating, right? So now this is again a simple diagram which is showing you a waterproofing of a wet area. So if you are having a bathroom where you have to do a waterproofing, so you can use various kinds of construction chemical products to ensure this entire waterproofing of an entire, inside area. Now, that is waterproofing is over. So now I will be talking about a bit about other segments like industrial flooring. So in industrial flooring segment, there are various kinds of additives or products which are available to harden the top layer of the floor. You can understand India is, there is a huge demand for warehouses, factory floors. Imagine Amazon, Flipkarts, Walmarts of the world. They're having so many big warehouses where heavy machines or heavy vehicles are being moved on top of it. So there are chances that when you're the flooring, the floor that the slab that is there on these particular warehouses, the top layer may chip off sometimes. So to harden that particular top layer, there are various ways you can do it. Either you can add some kind of hardeners to the concrete at the time of concreting itself, or there's something like epoxy flooring. So I'll show you, this is one of our products being used in Bangladesh. So you will understand how it looks like. So in a epoxy flooring, what will happen? There are four components which are there. There will be, one is a resin, one is a hardener, one is a filler. So a filler is nothing but like a sand, it looks like. And then there is a pigment. So the green pigment that you see over here is a pigment which was given to them. So usually what happens, you mix all of the four together and you will get a slurry like this. And this slurry is then, using various kinds of spiked rollers and all that, it is laid on the floor. So as you can see, he's just laying that particular this thing. So as you can see, he's pouring the same thing, and it is self-leveling only. So it levels on its own. Right. So I'll move to the next slide. Now, next I'm coming to the tile installation range. This is mainly including adhesives and grouts. So I'll just show you. Tile installation is very easy. I think many of you are already having tiles at your places, so you can, maybe you can make sense of it once you see this video. So this will show how a tile adhesive and tile grout is being applied. So first of all, you need to prepare the surface where the tiling is going to be applied, and then you moisten the surface, which is very important, because obviously for the cementation, if you don't moisten it, the cement will, absorb all the moisture of the cement and create a puffery effect. So you can see mixing of tile adhesive, he will do that. You can see he mixed the tile adhesive. So he applying it. So now you can see he's applied it, and now he's going to put the tile in this. So you can maintain a sufficient space between the tiles, in tile spaces. Now you can see the application of the tile grout. So tile grouts are nothing but the joint fillers between the tiles. Is mixed, it looks like a powder, then it is mixed with water, it forms a pasty. He's taking a straight edge, putty, call it putty. Is simply applying it. Then finally, what he'll do is he'll clean it. Final finished look. Okay, we'll move to the next slide. Then there is something called as grouts and anchors. Now these are also construction chemicals which are used. These are grouts and anchors are nothing but These are chemical compounds which are used to fill any cavity which is there. So as you can see, if you see this last photo, if when you are having say street lights, you will see when you're walking along the the roads of VIT and all, you will see there are street lights and all. Usually there is a bolt anchoring this is done. In order to anchor that particular bolt, you will have some kind of grout. So you can see the last image, it is the grout is poured so that it can totally keep that bolt in place, the bolt and the plate in place. So these are again cementitious products. You have epoxy based grouts also. So then fine. Next is joint sealants. Now, as I already told you, joint sealants, there are various kinds of sealants. There are silicone sealants, polysulfide sealants. So in roads, when you are moving through roads, you will see there are joints. You feel a little bit of a bump when you're moving through a PQC, pavement quality concrete road when you're moving. So these are, nothing but these are very highly elastomeric products. So it is applied in liquid form, and once it dries out or cures, it will form a very rubbery kind of a material. So these materials are then, these are mainly used to seal two joints between, seal a joint between two substrates. And their main purpose is to prevent the entry of air, water, or any other environmental elements while ensuring the limited movement of the substrate. The next segment is repair and rehabilitation. Now, repair and rehabilitation is, again a huge segment. Now, each segment over here, I'm just again what I'm doing is I'm only giving you a bit of a brief so that you can understand what is a construction chemicals. Just take the keywords, note down the keywords. You do not need to know entirely in detail in this session itself. If you are having interest, go back, read about it, because each segment is very detailed. You can actually spend days talking about each segment. So over here I'm trying to summarize 10 segments in 1 hour or so, and I can see it's already 1 hour 14 minutes. Anyway, I'm just 2 3 minutes away from my end of my presentation. So repair and rehabilitation products, again, is, there are many various kinds of products which you can have in repair and rehabilitation. There are cementitious based products. So right now, where would you use a cementitious based product? Like for example, if you have a column and which has kind of spoiled or broken up in places, you can repair that particular column using various kinds of cementitious repair, I would say free flowing repair mortars. You simply need to pour, or maybe in some cases like he has done over here, using a trowel you can put that particular repair material. Don't use cement sand, that is an old school way. Never use that, it will crack again. Use these materials like a micro concrete, or say there are other various kinds of repair mortars. These are ready to use. You just need to mix water with it. And the best part is that they give you strengths as high as 40 to 50 megapascal strength, 28 days strength. So obviously that's a better way to go about it. Then other than that, finally, there is other repairs also. Like in repairs, you can, I'm sure many of you have seen injection being applied inside the concrete. It is not the injection which you have recently applied for COVID and all. It's a kind of an injection which is applied inside the concrete. Now there are various kinds of chemicals which can be pushed through this injection. You can have an epoxy based, injection grouting. You can have cementitious based injection grouting. I'll just show you that you can have polyurethane based injection grouting. Again, it's a huge topic, long topic, but I'll just give you a little bit of a video so that you can understand it how an injection works. So it will help you. So yeah, so you can just see this video over here. You have a cracked surface. So what he's going to do is he's simply going to remove all the dust, dirt around the cracks using a wire brush, and then yeah, and then he's going to use this kind of a bonding agent. You can say this is a kind of a bonding agent, a pasty product, which he is kind of using it to seal those cracks. Why he's sealing it? Because he will be pumping in a chemical which will go in liquid form, and once it hardens, it will create a hardened material which is having strength as high as 70 to 80 megapascal. Just imagine. So over here, these are just packers. We call it packers. These are packers are nothing but through which you will be pouring in the chemical inside. So he's just putting it in place. Now what he's going to do is he's going to use this. he's going to inject the chemical, the epoxy I was talking about. So epoxies are nothing but these are mainly two component products. You will have a type a pack A and pack B. You can see he's in this case he's having both pack A and pack B, which is being poured from the same place. And now the when the pack A, that is the resin and the hardener, when they are mixing together, they will harden and they will create a very hard material inside that concrete, inside the crack. So now he is going to see, this is how the how the injection will happen. Now he will start the injection. So he's injecting it till the material comes from the next point, next port. He will inject it till that time. See, the chemical has now come from there. Now what happened? This means that inside that particular crack, this liquid has reached. And after that, this liquid, after say around 4-5 hours or 6 hours, this will harden out, and your entire cracking will, the problem will go away. Right. So finally, I did tell you about the fact that construction chemicals are contributing to a green footprint. How it is doing that? As I told you, it is first of all enhancing the durability of your concrete through waterproofing, because it is not allowing water to enter. Another way of this thing is that you can also conserve national resources like say cement. Now cement is also blamed for all the problems in the world. Right now the COP26 is happening. We have people are talking about the pollution in the world. The rule of thumb says a 1 ton of cement produces around 1 ton of carbon dioxide. So the more cement that we are losing because of some poor concreting and repair and rehabilitation issues, this means that much cement is getting wasted and more cement is being used to repair that material. So again, you can find ways to cement to save the cement also through use of admixtures, which is again a construction chemical. Then another way, another green footprint of construction chemicals is it uses chemicals like fly ash, microsilica, and GGBS. So I am introducing including these in in construction chemicals only. Microsilica again is a classic product, construction chemical product, which is a byproduct of byproduct of iron industries, and it is used mainly you can say for strengthening of concrete and all. Other than that, you can also improve the air quality via there are coatings which are photocatalytic coatings which are again which help in improving the air quality and all. Then you can reduce the energy consumption also. Now I did not talk about this topic, grinding aids. It's again a huge topic. That is something which we also do it with quite a few cement companies. These are nothing but these are chemicals which are added inside. So when you are making clinkers in a cement plant, that clinker is undergoes a grinding process where you are from say around 5 mm, the particle is brought down to 20 microns. That is the size which you use in cement when you are getting the cement at home. So these grinding in order to help the grinding and reduce the power consumption for grinding, imagine it is huge kilowatts, huge watts of energy are being used. To reduce that particular energy consumption, we can use grinding aids. So these grinding aids can help you grind that particular cement at a much lesser power because through its chemical action. Finally, I think I'm done with the entire presentation. I'm well in time. I'm happy to say that. So I have around 10 minutes, you can say, for the discussion. If anyone has a question or so, so you can follow me on my LinkedIn pages, Rudrabir Ghanti, or you can also follow our company page, Durabuild, where you can get a lot of information, a lot of good updates and posts are made, a lot of knowledgeable posts are being made on a regular basis. So you can go through that. Finally, I wanted to talk about this particular part, that construction chemicals as a career option in final semester projects. Many of you have reached a stage where you may be, either be going to be placed or you may be looking for a final semester project. So I would suggest maybe even get in touch with your guides and all. Maybe we can always discuss the same with Bala and all that, we can very well initiate, because I have already initiated a few projects which have, in fact, I've completed a few projects, MTech projects, which I've done with students in IIT Delhi. I do it all the time with many other universities also. I would be happy if my alma mater, VIT Vellore, is there. So if there are students who are interested to study or work on these products, maybe in their labs, or do various kinds of projects, because a lot of work has already been done into cement and fly ash. I really feel sad when people are doing the same thing in their final semester project. They are simply playing with the fly ash content, 30%, 40%. They are saying this happens, that happens, strength happens. Now I am telling you, construction chemicals is a massive field. There is a lot to understand. There is no understanding across India. So be the first person to do some academic research, and trust me, if you do a good research, you will have a lot of good citations. People will refer you work, because it's not a lot of work. Mostly the research that has been done in construction chemicals are commercial research, which are done by the companies themselves. So it is good if if you can come up, and as an academician you can do that research. It will be good for you also. And finally, thank you so much for patiently listening. And I would be open to any questions if you have any. Thank you so much.
Thank you, Rudrabir. You were explained in all the aspects like waterproofing and superplazzer for chemical admission for concrete, and the corrosion, and then epoxy flooring, industrial floorings, and then so and so. You are covered all the
Yeah, I
products.
tried to squeeze in as much as I can. It
Uh,
will be difficult in
uh,
1 hour.
I hope that students are enjoyed. Just we will get that feedback from anyone, any few
I
of the
would love to
students,
know feedback.
what they are feeling of. Uh, like
Yeah.
students, anyone can able to share your
Any questions?
feedback.
Anything? Any
Any
observations?
any questions if you are having, you just please ask to sir.
Good afternoon, sir.
Yeah. Good afternoon.
So my name is Ajit Prasanna. So I have one doubt. So the doubt is, so if the water percolates to the area of splicing, where the splicing and joints are there, so do you have to treat the by the same method, or we have to treat it differently?
See, obviously, every um, problem has a different way to go about the treatment. So if you are saying that the water has percolated through a joint, the type of treatment can also vary. The type of chemical that you want to use in that particular scenario. So I did not cover this. So in case you are doing injection grouting, the most easiest way of doing injection grouting is you can use cementitious. You can use a bag of cement. You can put water in it, and you can dilute that particular thing so that it becomes very slurry type. And there are various additives which can further help in increasing the fluidity of that particular grout also. So when you are having a moist area, you would much rather go for a cementitious kind of a grouting. But at the same time, if it's a dry area, or if it's a structural member where you want to ensure higher strength, then you may want to go for an epoxy kind of an injection grouting. So again, the method of treatment, depending on the area, whether it's a splice, whether it's a joint, it will vary based on the other requirements also, depending on the structural member, whether moisture is there or not. So various factors guide that.
Okay, sir. Thank you so much.
Yeah.
So good afternoon, sir. Here,
Yeah.
Satish Yadav.
Hi, Satish.
Sir, personal doubt, sir. Only so that, so for the further academics after the BTech, sir,
Mhm.
in this specific field regarding this construction chemical,
Mhm.
what should we could, what are the further academics that we could pursue, sir?
Uh, Unfortunately, Satish, what the problem is, there isn't much academic presence of these. Okay, we do these in guest lectures in various universities. So unfortunately, there isn't any validating, or you can say an accredited course in this particular field. In fact, I have already discussed the same thing with many professors in various universities and all, that there is a need to introduce this subject also, in the civil engineering students, because you cannot ignore construction chemicals right now. It is, I think, and Satish, it pains me when I go to site, when I meet these people, the guys who are selling these products, they have no idea about the product itself, what it does. They're simply selling it on the name of the product. The other person is selling this, I have an X, you have an Y, and we sell it. there's little academic understanding. One of the ways through which I can suggest you is, if you are that interested, recently, ICI, I think in Chennai only the head office is there for Indian Concrete Institute. They have recently released a book on waterproofing, a handbook, you can say. I would suggest you can read it. I think you will find it very useful. And I will share that link with Bala as well after the discussion. And maybe, that is a good starting point. So right now, unfortunately, Satish, you have to, rely on these kind of stuffs, all literatures which are available from various industries. But yes, if you are interested in doing a project on that one, on a certain product, because that will help you in enhancing your understanding, for that maybe we can talk on that particular matter with your guide also and all, and draft out a project. So during the project itself you will learn a lot of things about that particular chemical whichever you're working on. That is one of the ways.
Thank you, sir.
Hi, Rudrabir. This is Srinivasan from VIT. I am working as a first-term professor.
Hello,
It
sir.
was a very good presentation, and it is very informative. And you have given your 10 years experience in this one. So I hope, okay. So it was very nice. Only a doubt which I am having is the cost of the treatment which you are doing. What will be the cost of that treatment? Kind of, if you are doing for a restroom. Okay, mostly in conventional buildings, we have lot of problem in the restroom and the bathroom. Okay, definitely there will be the seepage, because I think we guys are using lot of acid for the cleaning of this salt accumulation.
Yes,
So
one thing, Srinivas, I want to point out here, we should not use that acidic base for cleaning purpose in
yes,
toilets.
yes, sir.
That we have to point out here. We
Absolutely.
should
Yes,
not use it.
Detergent based cleaners are also there that can be
yeah,
used. Yeah, in some
yeah,
cases, having said that, sir, I think the problem is genuine. We do uh, even the chemicals, even say for example a Harpic. I'm just giving a random example.
yeah.
So even if when you're using that for toilets and all, it has a slightly acidic content in it. In fact, when you go back, you read the contents, there will be an HCl which is there. So because an efficient cleaning can only happen, it has to have some kind of an acidic presence in that. So again, coming back to the question that he has put,
Yeah.
uh, a wet room area or a say a toilet or maybe whether it's a restroom or a terrace or whatever, the there is no singular, I would say, rule of thumb for
Okay.
the cost. So these costs can vary again because see, when you're doing a particular job, a waterproofing job, there is two aspects. One is the material, one is the labor.
Yeah, yeah, yeah.
Labor part is something which we can't talk about. It varies person to person. It depends on the quality that he is offering. So a labor in Chennai will be different than a labor in Delhi. That is another thing. So on a material front also, this industry is so, I would say there is so much of it's so unregulated, this industry. The same product, unscrupulous person is selling for 100 rupees per kg, but the legible price for that particular product should be 200 rupees per kg. So
Mm-hmm.
there are all kinds of people in the market, and that is a big concern again, that our industry's representation is very fragmented. Like
Mm.
in cement industry, there's a singular voice. So if one
Mm.
person says, the entire industry adopts those practices. In our this case, so for example, if we are offering a chemical for
Mm.
your repair purpose, which is having 40% solids, so automatically the price goes up to say 200 rupees per kg. On the other hand, there will be another manufacturer will come up to you, sir, you take it from me, I'll give it to you for 120 rupees.
Yes.
And he's having 25% solids. You as a user don't know. And you will simply go by the price, which is a natural thing to happen. So
Yeah.
that is why this industry needs a lot of recognition. Otherwise, the prices can really vary, and the prices can vary very, very, in a huge way. You will be wondering how come such a variation.
Yeah. In India, we have a bad practice.
Yeah,
Thing is, if there is any issue, generally person if he is having any issue means they will be taking to the vendor itself who is
Correct.
selling the material itself. That is
Correct.
a bad practice, I think. If any damages happened, if there is any problem, they should come to the institute. Yeah, that is a
Correct.
practice which they are having in the abroad. They will be bringing the problems to the institute, and the institute will be reading it, and they will be selecting the companies. They have their own what we can say, they have their own rights to select the company, or they will be finding, or initially they will be doing some research, afterwards they will be referring the companies. That
Correct.
practice is not in India, so
You are right.
we have
And
to.
that's where I think we need to have a strong professional body which
Yes, yes.
regulates this entire, because many people have tried. So having said that, there is this association called CCMA,
Mm.
Construction Chemicals Manufacturer Association, but it is all bogus. I think it's worthless to be.
Actually, I am why I am telling this one is, for example, yeah, individual residency means it is not feasible to industry also. But
Hmm.
if we are going for a flat system, okay, there they will be having around 100 bathrooms will be there, for example.
Hmm.
Okay, so if they are taking, it is a very large volume.
Hmm.
So that's why I'm asking this one. So when you are sending a material, when you are supplying the material also, it will be a huge volume. You can find out some the kind of reduction. Okay, you can reduce the cost of the material also, and
Correct.
that's what. And even you can send your technician also.
Correct.
Okay, your technician will be knowing more about this one. So
Correct.
whatever the house owners are doing, right, they will be seeing the product and they will be reading the procedure.
Correct.
Okay, they won't follow the procedure also, because they are not going to work, they are going to take a work from a work labor. Okay, he won't follow the
Correct.
same procedure also. 1 or 2 days he will be following it, the third day he will be going with this
Yeah.
conventional procedure. And
Yeah.
the thing in India is the labor is convincing the owner.
In fact, I'll tell you, these laborers, the so-called applicators who we call, many of the good ones are actually trained by us. So obviously, we as a company cannot go to every house. So what happens is we work through,
Mm,
any particular area we pick up. We train around 5, 6, applicators in that
mm.
particular area or belt, who
Yeah,
then,
if you are working, that means you can refer them, right? Yeah.
yeah, who are authorized to take jobs on our behalf, because we have trained them. They know how to use it. The best part is, or the worst part I would say is, the same construction chemicals, when it is not being applied properly, can
Mm,
actually become, a double-edged sword. Then you will say the product is worse, but
yeah.
the problem is not with the product. The problem is the applicator who is, using this product, and he doesn't know how to apply it.
Yes.
So
That's amazing.
that's applicator training we are doing, but as you rightly say, the industry is so small and so unregulated.
Yes.
You will have a lot of people. Everyone thinks that they are an expert in waterproofing. I'll tell you.
Yes. So it was very nice to speaking with you, Rudrabir.
Thank, thank
If you have a chance, means please come to VIT.
I am always thinking of an opportunity to, come down to VIT, but things are right now, after the pandemic and all. But now the floods and
Yes.
all. In
Mm.
fact, I'm still very closely connected to Professor Ghosh over there,
Yeah,
because
yeah.
semester project was with Professor Ghosh.
Oh,
We worked on various, cloud.
yeah,
Yeah,
yeah. He is a
he's,
very nice person.
he's
Still,
an
he is
amazing
working
person.
in VIT only.
Still there. Great. Happy to see. I think Dr. Kumar is no longer there, right?
Yes, yes.
Uh,
He went
as-
to his native place itself.
yeah, he went to his native place and all. But good to see Dr. Sairam is there.
Yes.
Sairam sir, I met him in IIT Delhi last time.
Oh, very
So
good.
now he's there. So it's very good to see him.
Yeah.
Yeah, I mean, I have a lot of good memories. I had some of the best memories in VIT Vellore. So I'm jealous of the guys who are there. Anyway, I'm not jealous of them. They have their study from home. So,
Yeah.
so it's an unfortunate bit. But yeah,
Welcome to Trivi. You are welcome. Please come to it. Thank you.
yes.
Thank you for a lecture. Very
Thank you.
informative.
Thank
Very
No,
informative.
no. We are planning to organize one national national conference
Yes, sir.
in upcoming years. That time I will invite you. You have to be there
Give
Sure,
a
in
sure.
lecture.
VIT.
I'll
Quick
love to be a
session.
part of it. Yeah.
You can
Mm, mm,
handle
mm,
a
mm.
session also. Yeah. Hands on
Mm.
hands-on workshop also we can plan it.
We do that in IIT Delhi all the time. We do it every year. We have this fixed this thing that where we go and show the products to the team, the students. And I would be very happy
because
to do
here we are doing it with Ultratech and then Ramco Cement.
Okay.
So many people are coming. And HIL, Hyderabad Industries Limited.
HIL is doing what with HIL?
Aerocon.
For the Aerocon, for the blocks, AC
for
blocks.
the AC block.
HIL is also trying to get into construction chemicals. In fact, we are helping them out on a few things also.
Okay.
Joint venture.
But again, HIL and Ultratech, although they are starting the construction chemicals division, but they don't know this division very well. I mean, they are relying on other parties to do it. So we eat, sleep, and drink construction chemicals.
Yes, correct. There is a differences there.
Yeah, absolutely.
Okay, right.
Okay, if you
anyway,
have
students, anybody having a doubt? If you having any doubt, you just.
So we are also eagerly waiting for that, sir. May we get that chance?
Okay. Right. Thank you.
So, one more thing, as a faculty, if you have any opening means, please let us know. We will send our alumni also, students. You please give them some jobs also. Okay.
First of all, MTech construction students.
Yeah, I've already talked about it. I think a good starting point would be that if one of you can take an interest in projects, because see,
the
students
definitely
can get this interest levels developed. So our session will not help them get the interest levels. Still, obviously, they all think that.
Due to that pandemic only, I didn't discuss about you regarding that project. But some of the students are going for the project internship, 9-month internship in that company.
No,
after once they are
So not that kind of project. So the project which I am talking about is, we can discuss.
Correct. This is related to construction industry.
True.
Some of the students are doing with cement industries like Dalmia Cement and then FL Smith. Likewise, they are doing in our laboratory. They are replacing our laboratory and doing that project with the company.
So I can tell you one thing. I mean, so much of work has been done in cement. If you pick up these 200 products we are manufacturing, sir, and if you start giving students, each student, one product to work on, you will find that there's so much of new data is coming through. And I'm assuring you look at anything, Indian Concrete Journal, any of the famous journals, even journals which are done abroad and all, CECR or whatever, you will see that there is no work in construction chemicals field, academic research. Even at a BTech level also, if students can simply basically just see that, because I'll tell you another problem, as Srinivas sir was talking about, many people are simply selling products in the name of construction chemicals, and they have little understanding what we are claiming it may help.
Yes.
They claim it 8-year warranty. I differ. Whether it actually gives you 8-year warranty or not, if that those things are specific studies, that.
Hello.
Yeah. Hello.
Students, if you are having any doubt, you just raise it, or otherwise we will close the session. Okay. Thank you. If you are having any doubt, you just yeah.
Balamurgan sir.
Yes, sir.
Yes, just 1 minute. Rudrabir sir.
Yes, sir.
Sairam sir is speaking with you.
I am very much thankful to you because I remembered my old days. Actually, when you are the person you made me to go from the bus stand to IIT Delhi in your own car. So I remember that one. And I was surprised actually how you gave 2 hours lecture, because as a faculty normally after 40-45 minutes will be very difficult. So I was listening
No,
continuously.
sir. Industry persons will speak for 3 hours, sir.
So I was a little bit surprised how you are giving 2 hours. So I could able to get some idea how to prolong 2 hours. And one
Yes.
doubt was there, that is actually regarding self-leveling.
Yeah.
Maybe it's already 16 minutes late actually.
Yeah.
So I'll call you sometime and I'll ask you. I'll take
Sure,
a
sir.
number from Bala.
Anytime, sir.
Only self-leveling was the doubt was there. I will ask. And I am
Sure.
thankful to Palamurkan and Srinivasan for allowing me.
Welcome, sir. Welcome, sir.
Thank you. Thank you.
Okay, sir.
Okay.
Thank you, sir. Thank you, Rudra.
Thank you, Rudrabir, for your wonderful lecture.
Thank you.
I hope enjoyed that lecture. That's it.
Thank you so much.
Because we are covering that admixtures like superclasses, naphthalene base, melamine base, or that polycarboxylate ether base. These and all in during that
Correct.
advanced concrete technology we are covering it. But lacking is there in that waterproofing and then. Rest of the sealant, joint sealant, and then epoxy flooring. These and all we are not covering in that syllabus. That's why I called you especially for this session and organized for our students. Some of the students from advanced concrete technology is there, and some of the students from construction materials and technologies attending these sessions, and then some of the students from MCT. Equipment, construction equipment practice students are attending there. I hope that this will help them when they are studying that repair and rehabilitation of the structures in that upcoming semesters.
Yeah.
Repair and rehabilitation of the structure is offering in that next semester.
Okay.
Those who are offering the subject, it will be clear to them to understand that what the faculty is teaching in that classroom. Okay. Once again, I will thank you.
My
You
pleasure.
are spending with us about 2 hours in your busy schedule. Okay, thank you for accepting our invitation on behalf of management, VIT Alumni Association, and because of School of Civil Engineering, and because of our student, I thank you once again. Thanks a lot.
It's my pleasure,
Okay.
sir.
I
My
look
pleasure to
forward
be.
your presence in VIT during that upcoming events. Mm.
Sure.
Okay, right.
Thank you so
Thank
much.
you.
Thank you. Thank you, sir. Thank you, everyone. Okay.